Anybody have any questions over the stuff we've been doing? I guess this is what we're about to do. We're about to do a recap of everything. Anything about class structure, anything otherwise, anything you need to bring up? I guess is what I'm asking. If not, we will get started on the quiz today. So we have a quiz today. I'm going to go through the quiz, talk a little bit about everything that we've done so far. And I hope you're looking at the quiz. I hope you printed the quiz out or have it pulled up. And I hope you've already kind of started on a little bit on it. And if you haven't, you got 3 minutes before I start on it probably. So hopefully you've given it a pretty good gander. I looked through it. Okay.
I had an issue trying to pull my quiz up off of the quiz 2 off of there. So is there a way that I'm supposed to do this? I don't know if I'm reading this correctly or.
So you should go to the quizzes and it should be in the quiz thing. And when you hit the quizzes, it should be under quiz 2. It should say attach file and you click on the attached file.
Okay, hold on. Quizzes. Quiz 2.
It should be a PDF file.
All right, hold on.
Okay, so let's go to the Joy-Can. Let's see if I can focus this a little better.
Okay.
It's probably legible. Maybe a little closer and get it better. Okay, so we're going to start out with this. What does it say? 2682 inches to yards. So in the table, they're probably not going to give me inches to yards. I highly doubt it. They tell me 1 foot is 12 inches and 1 yard is 3 feet. But they don't tell me anything about inches to yards. So how do I do this? So those are the things on the table that you might need to use. So how do I set this thing up? Okay. Or
You could divide the inches by 12 to get how many feet it is.
yeah, so I would set up a unit analysis. So if I'm dividing by 12, I think this is what you're trying to say. 12 inches is what I'm dividing by. 1 foot, 12 inches. And what's the other thing I'm going to do? I'm going to divide by 12. I'm going to do what?
And go feet to yards.
Yeah, feet to yards. So I'm also going to end up dividing by feet. So 1 yard is 3 feet. So all in all, you might notice you could do this one at a time, 2682 divided by 2, or 12, and then divided by 3, or you could kind of do it all at once, divide everything by 36, but you should be getting something like 74.5, I think is what I'm getting. So this feet and this feet, this inches and this inches, and this should be something in yards. And then hopefully, I hope you take a step back after you do this and like double check your answer. Does it make sense if I go from 2682 inches that I get 74.5 yards? So if I have a whole bunch of inches, the yard should be a little bit smaller. So I'm hoping you take a step back and look at your units and see whether your answer makes sense. 2 miles to inches. One mile is 760 yards or 5280 feet. So it might be easier. 5280 feet. So if I start with miles on top over there, where am I going to put my miles over here?
At the bottom.
Put it on the bottom. There's 1 mile to 5280. And it's in feet. Now I want something in inches. So I want to go from feet to inches. So I have feet over here. It is on top. I'm going to end up putting feet over here. So I still got to do another conversion from feet to inches. There are 12 inches in 1 foot. Okay. And like before I even figure this thing out, if I start with 2 miles, like I'm hoping you know that's going to be a shit ton of inches, right? A metric shit ton, I think, right? 2 times 5280. But like think about these things, right? It's going to be a really large number. So exactly how much is that? 1,26720, I think is what I'm getting on my calculator. And we're talking about inches here. $46.40 ounces to tons. So I'm starting out with a lot of really small measurement, and I'm going to a large measurement. It should be getting smaller. What do they give me? 1 ton is 2,000 pounds. Do they give me? 1 pound is 16 ounces. There we go. I knew that one. 1 pound is equal to 16 ounces. I know 1 ton is 2,000 pounds. Okay, and now we're looking at this thing. There are 46.40 ounces. 40. I'm starting with ounces on top. If you write out your units, I think it might help you. If I start with ounces on top, I want to put ounces on the bottom. If ounces are here, I'm looking at my conversion. I have one conversion with ounces in it. It's going from ounces to pounds. So there are 16 ounces for every 1 pound. The other thing is I'm going from tons to pounds. Have pounds here. I want my pounds to simplify. I'm going to put pounds on the bottom over here. So 2,000 pounds to 1 ton. So like I said, you don't have to know like the stuff from the table. You don't have to know these numbers from the table. I don't expect you to know those numbers from the table. But you got to know how to set these things up. You got to know whether you're multiplying or dividing. And I would really like to see unit analysis, if I'm being honest. Like this tells you how to do things. Although maybe you don't have to do it. If you do know how to do these correctly, go for it. But I'm really hesitant to tell you to do it any other way than unit analysis, because usually you're more prone to mess up if you do it any other way. Okay. And we have one last one to work within this table. So these are all coming from that first table. These are all just standard metric. Different from everyone else, so we have to learn our own table here. 3 gallons, 2 cups. So what do they got? 1 gallon is 4 quarts. Where are we at? 1 pint, 2 pints. 1 quart is 2 pints. 1 cup is 8 fluid ounce. So there is not a direct thing between what? Cups and gallons. So they do give us 1 gallon is 4 quarts. 1 quart is 2 pints. One pint is 16 fluid ounces. And we know what 1 cup is 8 ounce. And it says my internet connection is slow, so if I start cutting out, that might be why. So they don't give us cups to pints, right? How many cups are in a pint?
4.
2.
And it should be 2, right? 2 cups. 1 cup is 8 ounces. If we do 2 cups, that will give us 16 ounces. So I know this is like, yeah, it's not the prettiest. But if you wanted to say 1 pint is 2 cups, you could do that. But if we start out with 3 gallons, we can do it without even knowing that, I think. If we know 1 gallon is 4 quarts.
I have a question.
Yes.
So basically, if we just add it all up, it would equal 16 cups. So can't we just do the 16 cups and then just do the math that way?
You could do that. Yeah. Because that's what's happening. You're going to do what? 2 cups in a pint. And then there's going to be 2
Equal
here.
4, and then times 4 would be 16.
Yeah, you can absolutely do that.
Okay.
I was trying to set this up just so we have like a full unit analysis sort of thing happening. 3 gallons, 1 gallon to 4 quarts. We got 1 quart to 2 pints. We got 1 pint to 16 ounces. And then if we go back and convert ounces to cups. So we said there are what, 2 cups in an ounce? That's what you'll get if you divide 16 by 8 is how we did that. So if you do this the correct way, you don't even have to worry about that one conversion. So 3 times 4 times 2 times 16, and then we're going to divide that by 8. It should be what, 48? So if there are 16 cups in 1 gallon, there are 48 in 3.
Professor, I have a question on this one.
Yeah.
So I just expressed it as 1 quart equals 32 ounces. I cut right to the chase. Would you dock points on the test for that?
Does it have that in here? I'd be careful. I mean, with this one, you might be able to do it because you know the conversion factor. That conversion's not in the table, though. I was trying to make us pick stuff out of the table.
Okay, I see.
I don't see it in the table. It might be. Maybe I just don't see it. But to be honest, this one is probably the most difficult one you'll see. I don't know if I put one this hard on the test. There's quite a few conversions here. Maybe one like 2 or 3 conversions max. This one has what, 4? That's too many. Questions about these, about how to do these? These, I'm hoping, are straightforward. If not, practice them. Make sure you know how to do your unit analysis, do the unit conversions. So now we are going from standard to metric.
So Professor, did you say 4 times 2 times 16?
Yep, and then divide by 8.
And divide by 8. That's what I thought. Okay, thank you.
Okay, so I'm starting out with 5 kilometers. So there are 10 to the 3rd meters. So these values, and I know you've seen this table, but if we're looking at this table, these numbers are giving us the number of meters per, and then we look at the prefix. So they can put any one of these words after these prefixes. And I think we've seen an example of each in our notes of each of those. But 10 to the 3rd is the thing that I have for kilometers. The nano is 10 to the minus 9. One nanometer. Here. The important thing is not even what you're measuring here, right? It's that prefix that we're looking at. So if I start with 5 kilometers, the first thing I want to get rid of is kilometers. I only have this thing right here. So if I want to use this thing, 1 kilometer, I'm going to put that on bottom. And I'm going to put what, 10 to the 3rd meters up top. And so this is going to go from kilometers to meters. So another way you could say this is by multiplying by what, 1,000? 10 to the 3rd is just 1,000. And so now what's the next thing I want to get rid of? I have my meters on top. If I want to get rid of meters, they have to be over here. And I want to do nanometers. So there are 10 to the minus 9 meters for every 1 nanometer. So there are a few ways you can do this. But I have 5 times 10 to the 3rd, and then I'm also multiplying that or dividing that by 10 to the minus 9th. And I talked a little bit about this, but basically I have 5, and then I'm multiplying by things that are powers of 10. If I'm looking here, this is like 3 minus a minus 9 is what I'm doing to get this power. So there are a few ways. If you wanted to expand these things out, this would be 1,000. This would be a decimal place with like what, 8 zeros and then a 1, I believe. And then this is 5 times 10. 3 minus a minus 9 should give you 12. And
So you added it. It's not,
Mhm.
it's 3 and 9, it's 12 altogether.
this comes from, I have these two things. It's like I have a 10 to the 3rd over a 10 to the minus 9, right? I can look at these two things as being sort of over themselves. I'm like multiplying this by 5. I'm trying to figure out what power of 10 this thing is. And so the rule is we keep the base. If it's a like base and they're either being multiplied or divided, if they're being multiplied, it's added. If it's being divided, it's subtraction. So this is like 3 minus a minus 9. So this went back to the scientific notation in the notes and how we convert scientific notation. It looks very similar to metric, right? Because metric is base 10, and so scientific notation. but this should be 5 times 10 to the what, 12th. And so what that is telling me is that I have 12 zeros. So if I wanted to write this all out, 3, 6, 9, 12, and a 5. If I really wanted to write this thing out, I could write 12 zeros and I could say this many nanometers. Okay. 7,000 deciliters to milliliters. So, deciliters, decis, no, 1/10. So 1/10 or 10 to the minus 1 deciliter equals 1. No, wrote that backwards. Sorry. 10 to the minus 1 liters equals 1 deciliter. DL is what it is. Sorry. I don't need a deci. I always get confused between deci and deca. They're really familiar. They're really similar, right? One's an I, one's an A. And one's to the 10 to the minus 1 and one's 10 to the positive. So this is the 1/10, the fractional amount of liters, 2 milliliters, to which are 10 to the minus 3. So if I start with 7,000 deciliters. So I'm starting out with deciliters. The first thing I want to get rid of is what? So what am I getting rid of first here?
Deciliters or deciliters?
Yeah, I gotta get rid of these deciliters. So the deciliter, 1 deciliter to 10 to the minus 1. And there are other ways to convert these. If you know how to use this table, I might go over that. So the next thing I am done in liters. So now I'm going to go from liters to milliliters, sorry. And so I'm going to simplify. What it looks like is I'm going to have 10 to the minus 3 liters here. And I'm going to have 1 milliliter. So I need a little bit more room. I didn't leave myself enough room. So I have 7,000. I'm multiplying it by these things. So what I'm trying to say is like I have a 10 to the minus 1 over 10 to the minus 3. And going back to our exponent rules, that's like a minus 1 minus a minus 3. I have a lot of negatives in there. But that's like minus 1 plus 3 is like a 3 minus 1. I think this is giving us 2 more zeros. So I think I should have a 7 with 5 zeros total. 1, 2, 3. And this is going to be in, I marked it, milliliters. One way that people kind of use a shortcut with this table, if we're going from 1/10 or 10 to the minus 1 to 10 to the minus 3, you might notice that's 1 2 powers of 10. And And so you don't actually have to convert to liters in the middle. You don't have to use liters as like a middleman. Some people, they can use this table and they can look at it. We're going from something larger to something smaller. So large to small should be multiplying, and you're going by 2 powers of 10. So you'd have to multiply this thing by 100, I think is what we ended up doing, right? Right here, times 100. 10 to the second power would be 100. So if you can do that from the table, like, I would probably do this table on your notes or on your test. So if you wanted to show me that on a table or something, and then you understand how to do that from the table, that's fine. That's okay. You can absolutely do that. If you don't understand how to pick it out of the table, I want to see some unit analysis, or I want to see some sort of thought process that's correct. So now we're going from milligrams to kilograms. Okay, so from milligrams to, I think we have one. Grams and 1 into the 30 grams and 1 kilogram. So if you wanted to count the table, you might notice there's how many powers of 10 here? If we have 900,000 milligrams, y'all are awfully quiet today right before a test, kind of scaring me. But I'm also not taking the test, so I guess I shouldn't be the one most scared. But 900K milligrams. So how are you setting this up? You could also just acknowledge it's like a 10 to the third for both of them. That also works if you know how to convert that. Because when you work with a metric, all you're really doing is you're just moving the decimal place, right? You're not actually changing that number out in front. Ten to the minus 3g on top. Okay. So 1 milligram on bottom, exactly. 1 milligram on bottom, 10 to the minus 3g on top. And then over here, this is getting rid of milligrams. We're gonna want to get rid of those grams. So if we do that, we're gonna have to tag a 10 to the positive third on bottom, and 1 kilogram on top. Okay, so we have 900,000. We have kilograms, and I'm looking along here. These grams are going. I have 10 to the minus third, and then I'm dividing that by 10 to the third. So all in all, I should be moving this thing a total of 6 spots. And another way you can do that is you're going from what, small to big. You should be dividing this thing. So it should be getting smaller. If we're going 3 spots here and we're going 3 spots here, we're going a total of 6 spots smaller is another way to think about this, right? We're going to move that decimal place 6 spots. So if I want to move it 6 spots, I'm going to move it 3 and another 6 to right here. So what I'm saying is that this should be 0.9 kilograms, I believe. So you can set it up with the unit analysis if you want. You can move the decimal correctly if you don't understand how to move the decimal correctly. If I'm going from small to big, I'm dividing. If I'm going from, was it small to big, divide the big? Small to big, big to small, multiply all. That's what I was trying to remember. Big to small, multiply all, small to big, divide the pig. Something like that. 100 seconds to milliseconds. Or 10 to the minus 30 seconds. Every 1 millisecond. So if I do 100 seconds, this should be a quick one, hopefully. I want to get rid of my seconds. There are 10 to the minus third seconds for every 1 millisecond. I'm going to take 100 and divide it by 10 to the minus third. If I'm dividing by 10 to the minus third, that's sort of like multiplying by 10 to the third. I should be increasing this thing. I'm going from large to small. It should be multiplying by 3 zeros. I should be adding 3 zeros to this thing, essentially. Another way to think about this is 100. This is 10 to the, I should do it over here. This is like 10 to the second on top over like a 10 to the minus third on bottom. And then we do 2 minus a minus 3 gives us 2 to the 5th, or 5 zeros in there. And this is S as in seconds. Make sure you don't like see that as a number. Okay. Questions about this? Do you think you could do standard and metric? And then the next thing is what? Standard and metric. I'm hoping we can do these unit analysis and these conversions is what this is relying on. Now, we're looking at that table 2.4. 1 inch is 2.54 centimeters. Have the meters? No. So if I start with 100 inches, 2 conversions I need here. If I want to go from inches to centimeters, I want my inches to simplify out. So if inches is on top, I'm going to end up putting it on the bottom over here. 2.54 centimeters. And I want from inches to centimeters, and then I want to go from centimeters to what?
Meters.
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 And there are 10 to the minus 2 meters for every 1 centimeter, I believe. This, another way you can look at this is telling me to move the decimal 2 places to the left. So times 10 to the power of something, that's just telling you kind of where to put this decimal. If I want to do this, I got to do 1.54. Give me something like 314.96. I'm still multiplying that by 10 to the minus 2. So like I said, this 10 to the minus 2 is telling me move this thing 1, 2. I think I'm getting like 3.14, 3.15. I should probably round it up, but I didn't. So let's just go with it. Should probably be 3.15 meters, but I'm going. Let's be proper. Okay. And does that make a little bit of sense? If we look, we started with inches and we got something that was kind of small in meters. Okay, that makes a little sense, hopefully. Liters to gallons. So it looks like we get inches, feet, yards, miles, pounds. Where are we at? Very last one, I think. And I think the way they give you the table We can do 1 gallon is 3.758 liters, or 1 liter is 0.2642 gallons. If I'm being honest, I'm probably going to go with like this one just because it's a prettier number. I'm getting something like 1 gallon is 3.785 liters. You can use the other one. It'll just be like, instead of multiplying, you'll be dividing, or vice versa. I don't even know what it is yet. You got to do it. So 38 liters. And if I want to go from liters to gallon, where's the liters going to go over here?
At the bottom.
Yeah, 3.785 liters to every 1 gallon. And so this tells me I ought to be dividing these two things. So 38 divided by 3.785, it should be close to 10, which I think it is. 10.0396, 10.04, probably somewhere in there. And to remind you, we're in gallons. And we want to do pounds to grams. To have 1 pound is 0.4536 kilograms, or you can do what? 1 kilogram is 2.205 pounds. Either way, those should work. So for a lot of these, they're giving you 2 different ways to do the conversion, or 2 different conversion factors, but they are the same thing. They're just kind of flipped, right? Same thing with that currency table. We have like 2 different ways to do it. It's the same sort of like concept, right? Where they're just giving you the reciprocal. So either you're either multiplying by a number, or you're dividing by its reciprocal. Either way, you're doing the same operation. So if we look at this, 1 pound is 0.4536 kilograms. I know there are 1,000 kilograms, or 1,000 grams to every 1 kilogram. Or 10 to the third, right? Grams, 1 kg. So if I start out with 5 pounds, that's 5 lbs. And if I have my pounds over here, it's like my pounds are on top. And so over here, I'm going to want to put my pounds on the bottom. Over here, I want to put 0.4536 kilograms. So this will convert it to kilograms. Let's do some slashing. Slash, slash. That's getting rid of my pounds. Now I want to get rid of my kilograms. I want to go from kilograms to grams. My kilograms are on top over here. Probably want to put them on the bottom over here. 1 kilogram is 10 to the third grams. So it looks like I multiply 5 by 0.4536. And I also multiply it by 1,000. So it looks like I'm multiplying everything in this problem. And if I multiply everything, it's giving me an even 2268. So if you really want to sound like a strong man, just tell people how many grams you're lifting, right? Don't tell me you're lifting 5 pounds. I'm lifting 2,000 grams over here. Okay, for temperature, I didn't even give you a table, but I will give you these conversions. Fahrenheit, we have to multiply Celsius by 1.8 and add 32. For Fahrenheit, we do the exact opposite, or for Celsius. We take Fahrenheit, subtract 32, and then divide by 1.8. So these are actually the same formula. They're just solved. One solved for Fahrenheit, one solved for Celsius. But those are inverses of each other. It's the same formula. These are the same formula. We can convert Celsius to Kelvin, but we don't go directly from Fahrenheit to Kelvin, right? We have to make that middleman of Celsius if we do have it. So we have a few conversion things. 43 Celsius to Fahrenheit. So if you're doing this, we want to figure out what Fahrenheit is. We could use either this one or this one. So which one would you use? Would you use the first one or the second one if you're trying to figure out what Fahrenheit is?
First one.
The first one is solve for Fahrenheit. So go for that first one. F equals 1.8 C. So I'm not expecting you to remember any of these formulas or anything like this. Like these will be provided. You should know, I don't know, I wanted to say like any conversion, right? Any conversion sort of stuff you should know. Any of these formulas that are for conversion, or you shouldn't, you're not expected to know is what I meant to say. Sorry, said it the wrong way. Anything like this, I don't expect you to memorize formulas or anything. With that said, you should know things like what the difference is. You should know things like what is the relative difference. Those things you should know, right? New minus old over old, you should have that thing memorized, right? If you want to call it memorizing. I feel like we've used it enough. If you hadn't, if it hadn't stuck already, right, you probably hadn't been doing the work. I don't know. 109.4, and we are in degrees Fahrenheit for this guy. So this guy, we're going to multiply it by 1.8. We're going to add 32 to it. Questions about this? I think this one's pretty straightforward. Now we're starting with the other one. So if we start with Fahrenheit, and we want to go to Kelvin, and I kind of said this already, but what do we have to do first? We can't just go straight to Kelvin.
You have to figure it out in Celsius first.
Got to figure out Celsius. So Celsius tells me I take my Fahrenheit, which is 83. So now I'm using that other formula, figuring out Celsius. I'm going to subtract 32 and divide by 1.8. So I take 83, I subtract 32. I'm getting what, 51 over 1.8 is going to give me 28 and 3 repeating. And this is in degrees Celsius. So this is my degrees Celsius. This isn't what they asked for, but it is a middle step. So I want to highlight it a little bit. Now I want to go to what, Kelvin? So you could really use any either formula there, but the easier one to solve it from is probably this one. I take Kelvin, I take my Celsius, which is 28.33, and I add 273.15. Is that what it is? 273.15. I'm running out of room here. Let's do this. 273.15. There we go. Equals 301.48. And this is what, K? Fahrenheit and Celsius, they typically put the degrees on. In Kelvin, they don't. I don't know, it's a weird thing, but it's not something I'm like going to be super particular about, right? Okay, so 28.33 degrees Celsius, 301.48 Kelvin. And I'm not sure if I talked about it explicitly, but like, why do they do that with Kelvin? Why do they add 273.15? What's the purpose of Kelvin? Why did they make it? What is it going to measure? What is 0 Kelvin? Do y'all know that? Am I just speaking something weird?
Does that have to do with like the sun?
It has to do with energy, actually. It's
Energy?
0 Kelvin, that's known as absolute zero, right? And it's like known as like, it has to do with the energy in the particles. because heat is just a form of energy, basically, right? And so we're talking about, when we talk about heat, we're talking about how much energy is up in those particles. And they want to talk about 0 Kelvin, where there's essentially 0 energy in those particles. So they do this and they add this many degrees so that we can talk about absolute 0, basically. This is the thing that's going to measure absolute 0, which is 0 Kelvin, right? That says 0 Kelvin, not okay. Okay, so anyway, what about Celsius? I'm not too sure how Celsius is formed. Fahrenheit, though. Do you know how they did Fahrenheit? It's kind of stupid. I don't remember what 0 degrees is based off of. It was some kind of liquid, I think, maybe. But 100 degrees, do you know it's around 100 degrees Fahrenheit? And this is kind of why Fahrenheit is kind of stupid, the way it's derived or formed. Body temperature is 98 degrees, right? So I don't remember what the 0 was based off of, but you could probably go look it up, Google it right quick. But the guy that invented Fahrenheit, he based it off of the human body, which is not a good thing to like kind of base the system off of, right? Because the human body is variable, and like you normally it's 98, but I guess he based it off of his wife's temperature, and she was about 2 degrees over. So that's part of the reason why it's not a good system to base things off of. But that's where Fahrenheit kind of came from. The rest of the world uses Celsius, like good civilized people, but we'll use Fahrenheit. Okay. Because water freezes at 32 Fahrenheit. 0 degrees Celsius, right? That's water freezing, right? I believe. So that makes some sense. And then 100 degrees Fahrenheit, I think is, or 100 degrees Celsius, I think is boiling. But that is even variable, right? It depends what your elevation and what pressure you have. So those aren't always good metrics to rely on either. You put enough pressure on something, you can get something to just evaporate at a very low temperature, right? Stuff like that. A rectangular garden measures 13 feet wide by 32 feet long. So we have done the stuff from the table, picking stuff off from the table. Now they're going to give us a few word problems that are still converting stuff. So a rectangular garden measures 13 feet by 32 feet by, and they say 3 inches, but I would not look at the 3 inches. I would look at the feet. So we have feet by feet by feet. The store sells soil in bulk by the cubic yard. How many cubic yards of soil would you need to purchase and fill the garden? With soil. So if I want to figure out how many cubic yards this thing is, the first thing I might want to do is figure out how many cubic feet this thing is. So if I'm looking at this thing, I'm doing 13 feet. You don't have to. You can convert these 13 feet by what? 32 feet by 0.25 feet. And if I did this, this would give me something in feet by feet by feet. I don't want something in feet by feet by feet. I want something in cubic yards. So how do I do that? What is the conversion? There's 3 feet in 1 yard. So what is this looking like? I think it's going to go for 1 if you want. How many times do I need to do that? I guess is a good question. Huh?
Would it be 1/3 times 1/3 times 1/3?
Okay, so you want to go from feet to yards. So I got to think about this. There are 3 feet in 1 yard. So I think, did you say 1/3 or 3/1? I can't remember what you said now.
1/3, sir.
Okay, yeah, yes. 1/3 is the right way to go. We're gonna have to do this, and we're gonna have to do this. Like the whole kind of point of this problem is that we're gonna end up having to do it 3 times because we're in cubic feet, right? This is a dimensional analysis problem. So if we have feet times feet times feet, or if we have cubic feet, we're gonna have to do it 3 times. So 13 times what? 32 times 0.25. I'm getting something like 104. So this is going to give me 104 cubic feet. I'm going to have to divide by 3, divide by 3, divide by 3. Or I could have divided by 27, would have been the same thing. If I take 104 and divide by 27, right? 3 by 3 by 3 should be giving me the same number. Should be giving me 3.85 yards cubed, somewhere in that ballpark. All right, as long as you go to like 2 to 3 decimal places, you should be pretty safe. Okay. Anything I want to say? I feel like that's pretty straightforward with the unit analysis. We did a few of those. We did a few of those with the geometric stuff, and I kind of glazed over them, and I went a little more into depth in this section. Because I have yard times yard times yard gives me cubic yards, right? That's the other thing. Make sure your units are correct on this thing. Okay, so 1 cubic foot holds 7.48 gallons of water. And 1 gallon of water weighs 8.433 pounds. How much does 3.8 cubic feet of water weigh in pounds? And then they want to know in ounces. Okay. Do they still use that in the table? I can't remember if they say that. I think there's like different types of ounces. There's fluid ounces, and then there's the weight ounces, right? And they use that word to differentiate them, is what that's happening. Do they use that here? There's an apothecary ounce. There's a Troy ounce. Avoirdupois is like the regular weight ounce. So there are 16 ounces in a pound is what this is saying. £1 pound. That's the ounces that they're talking about. So they differentiate them. And typically, if I don't specify which ounces, I mean those ounces, the 16 ounces to a pound. Usually, if you talk about fluid ounces, you talk about fluid ounces. Those are a little bit different. So 1 cubic foot holds 7.48 gallons of water. So this is the thing that I would do. I would do 1 cubic foot, looks like 1 cubic foot. And this is my conversion factor that they're giving me. So I don't really know how I'm going to set this up yet. But I'm hoping like this is the sort of information you're picking out from the thing. Like if I have 1 cubic foot, it's going to give me 7.48 gallons of water, right? And if I have 1 gallon of water, so 1 gallon is going to be 8.33 pounds. And so then they say, we start out with 3.8 cubic feet of water. So if I'm starting out with 3.8 cubic feet, is the information that they're giving me. Oh, that is some horrible lag. Here we go. The first thing I'm thinking about getting rid of is that cubic feet. And so what do I know about cubic feet? This right here. So if I write out this information from the problem, if you write out the information that you know, God, it's like horrible lag. Oh man. Okay, I might have to restart this or something because this is like dreaded lag. Can y'all hear me fine?
Sounds good. Keep going.
For the
All
most
right.
part, yeah.
Sounds fun.
All right, 3.8 feet cube. Now it's getting better. Here we go. No more lag. Sorry. I'm going to get rid of the feet cube first. So I'm going to put that on bottom. See, I'm already done writing and it's still writing stuff. I want to get rid of my feet cubed. I know 1 feet cubed every what? 7.48 gallons. And now I have feet cubed taken care of. What's the next thing I want to do? Get rid of gallons.
Gallons, get rid of gallons.
So if I want to get rid of gallons, I'm going to write gallons on bottom over here to get rid of gallons on top over here. What do I know about gallons? I already used this one, so I'm probably going to go to this one. 1 gallon is what, 8.33 pounds? 8.33 pounds for every 1 gallon.
Then you have to do pounds, don't you?
That's where I'm going first. That's the first thing it asks, says, what is this weight of the water in pounds? So now I'm looking at this, I'm doing 3.8 times what? 7.48 times 8.33. I'm multiplying these three things together. That should give me 236.77, somewhere in that ballpark. And this is in LBSs. Where are you at, lag? There you are. Come on now, write it out. Oh, man. Yeah, I might have to restart this, man. It is like slow. 236.77 pounds. And if I go from pounds to ounces, you know you're either multiplying or dividing by 16. Pounds to ounces is big to small. I could do another conversion factor, but I'm going to skimp a little bit on this one. I know I'm going big to small. I should be getting a larger number. I should be multiplying. So if it's 236.77 pounds, I have to multiply that by what number? 16 to get 3788.32. And that would be in the ounces. Oh, man. Yeah, see, it's like still loading. I don't know if it's this lag is on your screen too, but it's like, it is bad. I have to fix this right quick. Okay, come on. There we go. Hopefully that fixes it. Pray the technology gods. Please, please work. Okay. Any questions over this? I think that's got it. 4-5, we're on 6. Use the
So
current.
did you divide 236.77 by 3?
We're multiplying this by 16 to get to ounces. So from pounds to ounces, you got to multiply it by 16. You could do it with unit analysis. If you put 1 pound on the bottom, 16 ounces on top, you would be multiplying by 16 ounces to get to ounces. So if we're looking at these tables, oh man, where is this at? Oh, they moved this around on me. That's why. Sorry. This is in the first table or in the first chapter. I forgot to move these chapters around. This is the table we're talking about here. So if you look in, what is it, 2A, I believe this is from. They swapped 2A and 2B, the tables around on me. So some of these problems might be a little bit out of order with like how I presented them a little bit. But same thing, we're traveling to Canada with 128 US dollars. 128 US. Without even looking at the table, I want to set this up so that it swaps to Canada. What am I going to put on bottom? What am I going to put on top? If I'm going from US to Canadian.
US.
What?
US on the bottom and Canadian on the top.
Exactly. We're going from US to Canadian. So this is telling me, and I got to go look at my table. I can pick one or the other. I can either pick this, what, $0.7586 for every 1 Canadian or 1.318 Canadian for every American dollar. So either way, 1.318, I think is the one I'll go with. So 1.318 Canadian for every $1. Either way you do it, you should be getting the same number. So I'm either multiplying by 1.318 or I'm dividing by that other number, the 0.7586. Either way, I've got to redo these because this table's changed since I last taught this. So 168.70, I think, is where I'm at. Does that make a little bit of sense? I have start with 128 in US dollars. It's going to cost 168.70. If you were an avid enough reader and you looked at the back of your books and looked at those prices when you were a kid, hopefully that makes a little sense. Do y'all like do that when you're a kid? Like look at the back of the book and it's like so much Canadian, so much US. Make you wonder, huh?
I did.
I did that.
Yeah, so you know Canadian's going to be a little bit more than the US, hopefully, right? Remember that. Use the context sometimes, it might help you. Okay, the next thing, you're traveling to Japan, we have 3,000 yen. So I don't even know what the conversion factor is, but I know I want to go from yen and I want to get my American currency. So I want to go from yen to dollars. How am I going to set this conversion up over here? What's going on bottom? What's going on top?
Would it be yen on the bottom?
Absolutely. Yen on bottom and the US dollars on top. And I have my two tables. So go look at your table. I'm either using 0.008658 or I'm using that 115.5. So this is giving me dollars per yen. This is giving me yen per dollars. So I know I have, let's go with the 115.5, I think is an easier number to write. 115.5 yen for every dollar. So I'm either dividing by a large amount or I'm multiplying by a fractional amount. Either way, if we start out with 3,000 yen, if you use context and like what you might know about like foreign prices, like it usually requires a lot more yen and usually requires a lot more, what else they give us? Yeah, I don't know. Pesos, it usually requires more pesos, right? So using your context and maybe what you know might help you out a little bit. But this is about 25.97 is what I'm getting when I divide these two. So I hope y'all are working along, and if you're not getting the thing that I'm getting, I hope you're checking, ask a question. Now's the time to ask. Because I might be wrong even, right? It happens on occasion. You're traveling to Mexico, we have $350. How many pesos can you buy? So we start out with US dollars, 350. USD. What is this conversion going to look like? What's going on bottom? What's going on top?
Would it be USD on the
US
bottom?
dollars.
And we're going from dollars to pesos. There are two different numbers we can use again. 21.86 pesos for every US dollar. So there are 21.86 pesos for every one US dollars. So you can either multiply by 21.86 or you can divide by that 0.04574. So I will give you a table with currency conversions. It may or may not be that same table. I don't know yet. But you should be able to do currency conversions based off of a table. 75.61. 76.51, sorry, I said it backwards. And just to recap, I am talking about pesos here. I don't remember. Japan uses the yen. Canadian, European, Euro, the yen, and the peso is what they have. Oh man, I'm trying to remember what the Korean currency is called for some reason.
I think Korea uses the won.
That's what it is, I think. Yeah. That's the common one too that I hear quite a bit.
Yeah, the won. I just looked it up.
Is it like Y-A-U-N? Is that how they spell it? Or
WON.
W-O-N? Won? Okay. Your utility company charges 13 cents per kilowatt hour. What is the daily cost of keeping a 70-watt bulb for 16 hours each day? Oh man, if I were to guarantee you like how people are gonna miss this, they're gonna miss it on this like first sort of thing that you do. We're charging per kilowatt hour. Guess what we want to know?
The kilowatt.
We want to know the kilowatt hour. If they're charging per kilowatt hour, we want to know how many kilowatt hours we're using. How do we find kilowatt hours? What does this mean? What does that hyphen mean? Ew.
What it mean? How many kilowatts you're using per hour?
No. Per means division, right? This hyphen means something almost the opposite. Yeah, this is the thing where people like they just like they see this and this is where they bomb the problem usually.
So if there's a hyphen, you multiply.
Exactly. Oh, I'm so glad you said that. Hyphen means multiplication. So I want to do kilowatts times hours. They're giving me watts and hours. What am I going to do with these two numbers? Well, I got to convert this to kilowatts. Fair enough. But I convert that to kilowatts. What am I going to do? I'm going to multiply by
$16.
I'm going to multiply by that 16 hours. So if you want to get kilowatt hours, I know they're not giving us kilowatts, but this is kilowatts times hours. We're going to multiply our watts by our hours. And like I said, we got to convert this so there are 1,000 watts, right? 1 kilowatt. So we do have to convert that, and that's probably one of the first things that we'll do. But you want to multiply your watts by your hours to find kilowatt hours. So 70 by 16 is giving me 1120. If I'm dividing this by 1,000, that's moving it 3 decimal places. It should be like what, 1.12? So this is using 1.12 kilowatt hours. And just to recap, this is what they're doing each day. So part 1, I don't think we really have to count for that it's each day. Part 2, they're going to ask us something about per year. So it's going to come up a little bit later. But if we have 1.12 kilowatt hours and they charge 13 cents per kilowatt hour, how much are they going to charge us? How do you figure that out? If I got 10 apples and they charge 7 cents an apple, how do you figure that out?
Times 365.
Yeah. So we're multiplying this by what? 13 cents an hour or kilowatt hour? You'd multiply it by 365 to get yearly, right? Is that what you're saying?
24? Is it 24? 24
No,
hours?
we're not converting the hours or time. We're just converting this to how much are they going to charge us? So they're charging
13.
They're charging
That's
13
13.
cents per
Yeah.
kilowatt hour, right? And we have 1.12 kilowatt hours. This was like more straightforward. 13 cents per every 1 kilowatt hour, right? This is like I was saying, if they charge 7 cents per apple and we buy 10 apples, we're going to be charged 70 cents, something like that. We're going to multiply these things together to find the cost. the units and then the cost per unit. 1.12 times 0.13. And I'm getting something like 0.1456. So this is not rounded. I probably want to keep this not rounded just so I have this number for the next problem, if I'm being honest. But this is about what, 15 cents is what this thing is going to cost per day. Okay, so if I have 0.1456 and someone already told me like how to figure out per year, if I want to know per year, that would be what, 53.14. And so to get from per day to per year, you'd be multiplying it by 365. Probably should be 365.25, but I'm being kind of lazy. So it's going to cost you about 53 per year. I don't need that. This is what they're asking in the problem, I think, right? What is the daily cost of keeping 70-watt bulb? How much will you save in a year if you replace the bulb with an LED that provides the same light but uses 10 watts of power? So what's going to change when in this thing that I just found? I did a lot of work here. I want to look along here, and what am I going to change? Is the 70 watts going to change?
Yes.
Should. That should be the main thing that changes. The 16 hours, they're still going to keep the light on for the same amount of time. Did it say that? You're replacing it, so it's the same light. It's the same time. 1 kilowatt is still 1,000 watts. This is the number we got from that. After we got that number, we multiplied it by 0.13. This got us our cost per day. We multiplied by 365 to find the cost per year. So it should be the same process, but now instead of 70, hey, guess what? I threw in 10. And I think you could take this whole thing, you could probably just take the whole thing and divide it by 7, and it would probably give you the same result. But I'm going to go ahead and solve it step by step. So I'm getting 0.16 kilowatt hours when I do my first step for my 10-watt bulb. And when I multiply this by what, 0.13, I'm getting it cost me 0.0208 per day. And I multiply that by what, 365, and this is 759 and 0.2 of a cent per year is what it looks like. And so if we want to know the savings, what's the savings that you're getting on this thing? The yearly savings on this thing, how would you figure that out?
Would you subtract it from 53.14?
Yeah, exactly. 45.55 per year is what 50. I said it and I didn't write it. Oh, that's horrible. 45.55 per year. Yes. Okay. And that's coming from this minus this. I think you could probably also take what, 15 minus 2 cents and then multiply that by 365. That will come out pretty close. So you could do the date. This is again like one of those math things, right? There's multiple ways to sort of get at this. If we do the per year price minus the per year price, it gives us the per year savings. If we wanted to do the daily savings, right, we could do 15 cents minus the 2 cents would give us 13 cents. 13 cents by 365 would be $47, $45. It's all in the same ballpark. That one was a little bit more because I rounded, right? This one is a little more accurate because I didn't round as much. Questions about this approach. So I think one of the hard things that students don't remember is kilowatt hours literally means kilowatts times your hours. We take our watts, we multiply by the hours. Then you might have to convert your watts to hours to get kilowatt hours. So there might be a little bit of decimal swap in there, but you should be able to get kilowatts, kilowatt hours. When you get kilowatt hours, that's how you're being charged. You should be able to multiply it by however much you're getting charged per kilowatt hour. You should be able to find the cost per day. You should be able to find the cost per year. And this thing is exactly parallel to that previous thing. We take the two amounts and we subtract them. So this is something you should be sort of familiar with. That is what, 7. Okay. Go a little, well, those will go quicker. A lot of those percentage ones are just like, is this correct? No. What is the density of the wood? So we got a cube of wood that is 5 centimeters in length on one side, and it weighs 1,000 grams, or 100 grams, sorry. And then the next thing says, will it float in water? The density is 1 gram per centimeter cube. So that is giving you like a hint as to how density is measured. It's in grams per centimeter cube. And so if you wanted to replicate that, how would you do it with this information they're giving you? You start with what on top? So what's on top here?
Centimeters cubed or grams?
The grams is on top. So what I would do is I'd start out with the grams on top. So we want 100 grams on top. And we want this over centimeters cubed. So how are you going to get centimeters cubed from a cube that is 5 centimeters on its side?
Is it 125?
Yeah, it's 5 by 5 by 5, right? Is what we're doing, I believe. Another way to think about density is that it is mass over volume, right? I think we said that. So if we want to know the volume of a cube, it is just those 3 sides being cubed. So what I think we're getting is 100 grams over 125 centimeters cubed. 100 over 125 is what, 125? 0.8? 0.8 what, grams per centimeter cube? So this is part A. Part B says, will it float or sink? It's a 50-50 shot. So if water is 1 gram per centimeter cube, is this thing going to sink or float?
Float.
It's going to float because 0.8 is less than 1, right? So it is lighter, is what this thing is saying. It is less dense, it is lighter, it is going to float. That's absolutely right. If it was over 1, would it float or sink? So if I got like 1.23.
Sink.
Yeah, this would be a sink. Let that sink in. Okay. Complete the following statements. If Robert is 68% taller than Ahmad, Robert's height is what percent of Ahmad's height? And then the other thing says Jennifer's salary is 75% of Susan's salary. Jennifer's salary is blank percent less than Susan's salary. So this was the whole thing with like the greater than, less than, of sort of vocabulary with the percentages. But if he's 68% taller, how much of Ahmad's height is he? How do you figure that out?
He's just 168, right?
Yeah, exactly. He's one of them and another percent of them.
What about question 9?
Good question. I guess I skipped over that one. We'll go back up in just a second. Jennifer's salary is 75% of Susan's salary. Jennifer's salary is blank percent less than Susan's salary. This one is a little weird, maybe.
Is it 25%?
It would be 25% less. So 100 minus P, we did 100 plus 68. We'll give you 168. This is a little different, although I think you can kind of interchange it. It really should be going that way, but I think it works out either way, the way that you do it if you're subtracting something from 100. So 100 minus 25 should be giving you the 75% of, is usually the way that we did it. Although you could go the other way and it's still 100 minus 75 gives you 25, right? Jane's salary increased from 32 to 41 over a 4-year period. Mark's salary increased from 33.70 or 25 to 33.75 during the same time span. Whose salary increased more in absolute and who's in relatives? So Jane and Mark. How do we get absolute difference or absolute, what does it say? Yeah, absolute difference, absolute increase. Anytime they say absolute, what are we doing? So for like Jane, she's going from 32 to 41. How do we figure out her absolute? What are we doing with those two numbers?
New minus old.
Subtract.
Yeah, it's just new minus old. So this one is just a straightforward, what is the difference? How much did they increase? So between those two, I'm getting 9,500. And then Mark is going 33,750 minus 25 is going to be 8,750. So who increased more absolutely? It looks like Jane is a little bit more. Numbers are equal. Okay. And so that is absolute. If I want to know relative, and if you really wanted to save some time, you could probably save some time on this. You've already solved part of it. 1,000. What am I going to divide this first thing by? I'm going to take this difference and I'm going to divide it by
The 32.
the 32. So hopefully you're getting the right reference value underneath there. So this is 9,500 and we're going to divide that by 32,000. It's going to give something like 0.2969 if I round it up. And so what is this telling me? Her increase is, I didn't write it on here, but I should really convert this to a percentage. So her increase is going up about 30%. His increase should look similar. I'm going 33,750. I'm subtracting that other thing, which is the 25. And I'm dividing by the
25.
By the 25. 33,750 minus 25,000. And then I divide that by 25,000. This is giving me something like 0.35, which is telling me his increase is around what, 35%? So who's had the more relative increase? So we're talking about 29 versus 35. So it looks like Mark had the larger relative increase is what it's looking like. Which is in part because he started with a lower number, right? So we ended up dividing by a lower number. So that's part of the reason why. Our reference value is smaller. Okay. So you should know, like, by the definition, you should know what like the absolute terms are, the absolute difference, the absolute increase, or the relative increase, right? You should know what that vocabulary means. You should know what like those sort of formulas look like. We're doing new minus old, or we're doing new minus old over old. So, and question 11, in 2014, the percentage of online adults using 2 or more social media accounts was 42. And 2015, the percentage of online adults was 52. So what is the percentage points increase? And this is going back to percentages of percentages. What does it mean when we say a percent increase? What does it mean when we say a percentage point, right? Those are very different. Those are two different things. So if we want to know percentage points, that's like which one of those things that we just found on the previous page? Absolute or relative?
Absolute.
Yeah, so this is just the absolute change between those two things. 52 minus 42. So I would say 10 percentage points. So this thing increased by 10 percentage points. The other thing is, oh, it says it right here. Okay, 52 minus 42. We're going to end up finding what 10 out of 42 is going to be. So 10 out of 42, and then convert it to a percentage. 0.238, I think is what we're getting. We're talking about what, 23.8%. So this thing increased by about 23.8%. So this is a largely just a sort of vocabulary thing. If you know what absolute and know what relative changes are, this is talking about absolute, this is talking about relative. So you should know percentage versus percentage point. And I think that problem is mainly just vocabulary and knowing which one is which, right? It's not really any different, but there are a lot of percentages in here, so maybe that also gets confusing because we're doing percents of percents. Okay. So Anthony thinks that if his tax rate decreases by 12% for the next 3 years, then his tax rate will decrease by a total of 36 over the next 3 years. Is he correct in that assumption?
No, not exactly.
No, not exactly. Okay, so like, maybe give us like an example of like why it wouldn't be correct. So we start off with $100 in taxes. The first year it's going to get reduced by what, 100, and we're going to reduce it by 12%. So we're going to take off what, 12%? Which is giving me what, 88? And we're doing what, 88, and we're going to take off 12%. But what are we taking 12% of? I think that's an important thing here.
88.
We're taking 12% of 88. Like 10.56. If we crunch that. So we're doing 88, we're taking off 10.56. And now we have 77.44. And now we have the same sort of problem, right? We have the 77.44, and we're taking off 12% of the 77.44. Or you could also do 88% of 77.44. And we end up with something like 68.15 or something, right? And we're looking at 100. If we start with 100 and we take off 36%, we should be ending up with 64. We ended up with 68. So are you going to be happy that you have to pay $4 more? Probably not too happy, right? And do you remember what this thing was called? If you give me like an example like this, I would be happy. You would get complete credit. Or if you told me something like this is a shifting reference, I would probably be happy about that too. We teach 2 separate classes. Your first class, which consists of 27 students, has a mean score of 83 on the midterm exam. Your second class has 14 students and they have a mean score of 85. Does it follow that the mean score for both classes combined is going to be an 84? And so what they're doing is they're trying to like what? Take 83 and 85. And they're trying to average these things, right? To give you the 84%. Does this follow? And you can throw some numbers in here if you really wanted to. But is this something that you should do or should not, and why not? And why should you do it if you can do it? Do you remember what this was? So this is like you have your 2 classes separate in the grade book. And if you put them all together, is it going to give you the same average? What's that? And you put them all together, is it going to be the same average? I can't, you're cutting out right when you say what you're like, what's important. It's like, I can't hear it. It's like, this was kind of like that quiz and test problem I had in the notes, if you remember that thing. And I think we worked it in the homework as well. But typically, what about this thing? They say don't average percentages is what they tell you, right? And this 83 comes from 27 students, right? This 85 is coming from 14 students. So when I go and compile them together in the grade book, it's not going to be that. Right? If you had like 85 being added, if the average is 85, you could like literally add the 85 like 14 times. You could add what, 83 27 times and figure out what that is. That's one way you could probably figure out the average of the class, right? Plus what, 27 by 83. And I have to divide by the total number that's in the class, which is 14 and 27. So I would be getting an average of 83.68 if I actually crunch the average of this class, I think. So I'm not really expecting to crunch all those numbers on this one, if I'm being honest. The thing that you should take away from this is that they are averaging percentages, and they're averaging percentages that are coming from different sample sizes, right? And so in general, you don't want to average percentages, especially if you got different sample sizes. It doesn't work. So the main thing to take away from that is don't average percentages. convert to scientific notation. I don't want to spend too much time. This thing should be getting larger by 5 decimal places. So 5.48,
Mm,
3, 4, 5. It should give me 548,000. This one, I'm moving this one to the left 3 spaces. 0.003143. So this, I'm hoping you can convert from scientific notation to standard. And I'm hoping you can go from standard to scientific. They're 3, 6, 7, 8 is what I want to do here. 8 is going to make this a large number, positive 8. This one should be a negative number because it is a small number. I'm going 3, 6. I have to go 7 places to make that 4.63. I have to go 6.89, and I have to go 2 places on that one. So these, if I give you something like this on the test, I hope it should not take you very long to do one of these, right? Converting from standard to scientific, from scientific to standard. Use table 3.1, determine how many average candy bars an adult would have to eat to supply the energy for 5 hours of running. Okay, we're past percentages. We are in part B. So this table was in 3B. Energy released by metabolism of 1 candy bar is 1 times 10 to the 8 joules. And then 1 hour of running it gives us, where is it? 4 times 10 to the 6 joules. Okay. So again, I know my conversion factors are simple as 1 candy bar as compared to what? 1 times 10 to the 8 joules. And I know 1 hour run is going to give me 4 times 10 to the 6 joules. So if joules are on bottom here, I think I want to put joules on top over here. So 4 times what? 10 to the 6 joules for every 1 hour run. And this looks like it's going to give me something in candy bars for every 1 hour run. So 4e to the 6. And we talked a bit about like how to do things in scientific notation, but this looks like I'm getting 4 times 10 to the minus 2 divided by 8. Is that what it is? About 4 over 1 being separately from 10 to the 3, so 10 to the 8. Okay. So that is 0.04 candy bars for every 1 hour. This was not an even number. I should have done these numbers better, maybe. And if we want 5 hours, it's going to be what? If we want to do 5 hours, or over here on the bottom, we can run for 5 hours. This should be giving us something that gives us the total candy bars for 5 hours. So we'd have to multiply the 0.04 by 5. And so what it looks like is that we're going to have to eat 0.02 candy bars. Okay. And it is 2:37. I'm trying to get through these, but we've got like 5 more. There are approximately 4.2 million births per year in the country of Ghidorah. Express the number in births per second. So 4.2 million. So if you want, I'm going to go ahead and write that thing out. That is that number right there. 4.2 million births per year. And we want to go from years to seconds. So if years, 1 year is here, and there are 365.25 days. We want to go from days, and then we want to go from days to hours, and hours to minutes, and minutes to seconds. So I'm running out of room here, but let's do 1 minute is 60 seconds. So if I'm going with 4.2 million, 4200000, I'm going to divide that by 365.25. That's going to give me around 11,000. I'm going to divide that by 24. So we've done this a few times. This is converting from what, years to seconds? I'm getting something like 0.13. The next thing, 18, almost there. So use the table to answer the following. Suppose you need 15,000 to maintain a standard of living in 1977. How much would you need to make the same standard of living in 1999? So this is the last section I did. So like I was saying, if you write your equivalent fractions, you can get these things done. So we want to go look at that table with the CPI in there. Ooh, the table's different. That's the one that's different. 3.2b is where this is. No, this is in 3D is where this is going to be located. So if we go to 3D, let's see. Their table is going to be different from what mine is in my notes, I think. Do they have gas? Here we go. Let's see if I can share this. So I'm wanting to go from 1977 to 1999. And the other thing I might want to pick out is the standard of living for 2008. So 1977 is going to be 60.6. 1999, I am getting the number 166.6. 2008, I'm getting the number 215.3. So these are the numbers we can pick off of this table. There's my CPIs that I need to get. And then they say I have 15K in 1977. They want to know how much that's going to be in 1999. So we just got done with the section last time. but this is a 1977 class or price, and we're gonna put it in 1977. We don't want to know what the 1999 price is, so we talked a little bit about this, but this is like cross multiplication. So if I multiply these two, 15,000 times 166.6, and then I divide by the other thing, I should be getting my solution. So I'm getting this should be somewhere around 41,237.62. And that's coming from cross multiplying. How much would you need to maintain the same standard of living in 2008? So I'm still going from 1977. I'm writing the wrong date here. 1977 to 2008. So 1977 has a 60.6 CPI. 2008 has a 215.3 CPI. And I want to go from 15,000 to some number. And so this is the same thing. I'm doing 15,000. I'm multiplying it by 215.3, and then I'm going to divide it by 60.6. I should be getting something like 53,292 and 8 cents when I round it up. So I know I'm going through this a little quick. If you got questions, you can still ask them. But what I'm doing is I'm cross multiplying these things. I'm multiplying this thing, and I got to divide by that thing that's on my X. I'm writing equivalent ratios with the CPIs compared to whatever information they give me to compare the 2 years. Okay, so now they're going to give us the change in price of tuition. And
That's
so
a
they,
quick question.
yeah,
So on the test, all these, the CPI, the points and everything are going to be provided for us with.
yeah, anything on a table, anything with like a sort of formula should be provided. About the only thing you might have to memorize that I can think off like the top of my head is like new minus old divided by old. You might have to know what relative difference is, but everything else that's like a formula for the most part will be provided. These CPI values, I don't expect you to memorize CPI values, definitely. That seems crazy. So we want to know what the relative change in this thing is. So 67 minus what, 1770 over 1770 will give me the relative change. So we talked about relative change, what that means. And then I got to convert to a percentage. So I'm going to say some middle steps because we've done this a few times. So 6,700, I'm going to subtract 1770. And I'm going to divide that by 1770. Give me 2.785, somewhere on there. And I want to convert that to a percentage still. This is 278.5%. So almost a 300% increase in price. Which makes sense if it's going from what, 2,000 to 6,000? It's about 300, 3 times the amount. Okay. That, and then the other thing, 91 and 2009. So that you're gonna have to go back. 91 on our table says 136.2. And 2009 says 214.5. And if I want to know inflation, how do I find inflation given the CPI? What is the, how do those things relate? So that you might have to know as well. Like, what is inflation? So how do I find inflation for my CPIs? Does it say? What sort of change is this thing? Okay, so the inflation is the relative change in your CPI. So this is something that you will have to know for the test, is that the relative inflation, is the relative change of your CPIs. So we want to find the relative change of these CPIs. $214.5 minus 136.2 divided by 136.2. I'm getting 0.5749 if I round it up. So what this is telling me is that inflation is around 57.49%. And I know I didn't ask it, but if you wanted to compare inflation to like the price of your education, you might notice that your education is going up by 300%, while the inflation is only going up by about, 60. Okay. I think we got like what, one or two more? We've got two more tables to look at, right? The last section. So inflation is the relative change in your CPI. That is something you will have to know. Inflation is the relative change in CPI. Oh man, they're giving us something fractions. 81 divided by 87. Let's convert these to percentages or something. Or at least the decimals. Let's get the decimals. 1.93. Oh, we got the same base. To convert these to decimals, 234 divided by 270. They will be a lot easier to compare. 0.86 repeating, 0.87 is probably pretty good. 192 over 263 is 0.73. If you convert these to decimals, it might be easier to do this problem. 0.6. Which treatment did better with smaller stones? So we're looking along here with smaller stones. We're looking at what? 0.93 voice versus voices. Voices, 0.87. The 0.93 would be larger, so that would be treatment A. Which treatment did better with large stones? It looks like treatment A again. Which treatment did better overall? Okay, so this is something we might have to calculate. So treatment A, if we're looking at both of them, 263 plus 87. This is out of a total of 3. This thing healed 81 plus 192 of them, which was 273. We just did an example like this in the notes last time. Look at that there. 270 plus 80. This is also out of 350. But 234 plus 55 is going to give me 289. And I want to look at 289 out of 350. That's giving me about 83%. If I look at both of them combined, I'm going to notice that treatment B did better when I combine the two groups. And so this is that sort of problem when we look at the group separately, or if we group a certain action separately, then the whole, we get a reverse sort of trend and explain, is this possible? Yes, it's possible. Does anybody remember what this thing is called? Where if we group it, we get an inverse sort of trend, then if we put them together. It's the one with the yellow people. It's Simpson's paradox. So this is an example of Simpson's paradox. So you should be able to take something, you should be able to tell me, if I give you fractions, you can put them into decimals. You can tell me which one is better, which one has a larger percentage of treating things. You should be able to look at those numbers and crunch them. You should be able to combine the two things, the two groupings. So we're adding the denominators on both to do all the occurrences. We're adding the numerators on both to get all the successes. We're taking them all together, and then when we take them all together, they have a reverse sort of trend. Okay, so this says the following table shows a summary of 1240 mammograms. The table is used as an assumption that 5% of breast tumors are malignant and that mammogram screening is 90% accurate. So they want us to verify the numbers. So really there's two numbers. If I'm being honest, I probably won't give you the verifying the numbers on the test. I'm probably going to give you the table itself and then just like make you out. But if I take 5% of that 1240, I should be getting that 62. Or 62 out of the 1240 should be 5%. So that's one number we need to verify. The other thing is the 90%. So 90% of the 62 should be giving me that 56 that is there. And there might be some rounding, but it should be pretty close. I made it right. 0.9 times what, 62? Yeah. Suppose a patient has a positive mammogram. What is the chance they really have cancer? So these are the sort of questions I would probably really focus on this problem, if I'm being honest. They're going to suppose something. Suppose they have a positive mammogram. So that is going to narrow down. So now we're only looking at this row that says positive mammogram. So the second I see that they're giving me some sort of stipulation, like that should be narrowing things down. So now I'm only looking at these three numbers. The only three numbers you should put on there, well, you should probably only put in two numbers, but they should only come from these three numbers. So suppose you have a positive mammogram. What is the chance they really have cancer? So the occurrence out of the total, the chance that they have cancer, there were 56 of them that had cancer. Out of the total is going to be 133. So if I'm doing 56 out of 133, I'm getting like 0.421 or 42.1%. So suppose you go and have a test, you have a positive mammogram, what's the chance you really have cancer? There's only like a 42% chance that you have cancer. So there's actually probably a larger chance that you don't. So then again, this goes back to that thing. Why are they even taking a test if it's not that accurate? Because you're going to take another one. And it's better at rejecting people that don't have it than it is at telling you that you do have it, right? What is the chance of a negative mammogram given that the patient does not have cancer? So now they're telling us they do not have cancer. So this is narrowing it down. I should only be looking at the thing where they do not have cancer. So they're giving you this. So what is the chance of a negative mammogram? So I'm looking along here. The negative mammogram is the 1101. There are 1101 people that have a negative mammogram out of a total of the 1178 benign. So 1101 out of the 1178, that should be most of them. I'm getting 0.9346, or about 93.46%. Okay. So these are all things that should be applicable. They could be on your test. If you have any questions, I'll stick around for a few minutes. But I think that's the final thing. I kind of have the test kind of made up. I still need to do a little bit of editing on it probably, but